Hey everyone, welcome to today's explainer. We're diving into something that literally sounds like it's straight out of a sci-fi movie, but it's happening right now in our own cosmic backyard. We are talking about a mysterious new mini-moon that was just visited by a spacecraft. Get ready, because what we're looking at today challenges what we thought we knew about the rocks orbiting our planet, and we're going to break down the exact science of how it all works.
Here is the roadmap for this explainer. We're going to meet Earth's rare mini-moon, figure out what a quasi-satellite actually is, look at the asteroid Kamoʻoalewa, track the Tianwen-2 space mission, and finally ask, is it a piece of our moon?
Okay, let's dive right into Section 1, meet Earth's rare mini-moon, and its 1 billion kilometer journey.
So let me just ask you this straight up. Does Earth have a second moon? I mean, you look up at the night sky and the answer seems pretty obvious, right? Just the one. But space is, it's full of surprises. And lately there's been a ton of buzz about a so-called second moon just kind of hiding in plain sight.
Well, that brings us to some absolutely massive news. China's Tianwen-2 spacecraft literally just snapped the first ever close-up image of a mini-moon named Kamooalewa. This is a huge deal. For the very first time, scientists are actually getting a detailed look at this mysterious object. And it's not some perfectly smooth round sphere like our actual moon. Nope. It's this incredibly jagged, deeply rugged space rock.
So, Section 2. What is a quasi-satellite? Let's break down the actual science behind this mini-moon.
Now, despite all those catchy headlines you might have seen calling it a mini-moon, Kamooalewa isn't really a true second moon. It's actually what scientists call a quasi-satellite. Basically, it's a super rare asteroid that travels around the sun just like we do, but it stays gravitationally linked to Earth. Because of this really unique cosmic dance with our gravity, it stays super close to us for long periods. So if you're standing on Earth, it totally appears to circle our planet.
To picture this, think of our regular moon. It orbits Earth directly, right? Earth is dead center. But a quasi-satellite actually orbits the sun. It just traces a path that keeps it lingering right by Earth. It's kind of like a runner on an outer track who's perfectly matching our pace. It looks like they're doing circles around us, but really, we're both just running around the sun together.
Okay, Section 3. The asteroid named Kamoʻoalewa. Let's measure this mystery.
40 to 100. That's Kamooalewa's estimated width in meters. To really put that into perspective for you, this entire celestial body is roughly the size of a football field, maybe even smaller. In the giant, endless expanse of space, that is literally a speck of dust. Tracking down something that tiny out in the dark is an absolute triumph of modern engineering.
And to grasp just how special this little rock is, you only need one number: 7. That's it. Scientists only know of 7 quasi-satellites hanging out near Earth. Out of the millions of rocks zipping around out there, 7. This specific gravitational setup is just exceptionally rare. So Kamoʻoalewa isn't just random space debris. It's honestly one of the rarest objects in our entire cosmic neighborhood.
Which brings us to Section 4, the Tianwen-2 space mission, and how we actually chase this asteroid down.
Let's walk through this incredible timeline. The mission launched on May 29, 2025, kicking off a staggering 13-month journey across nearly 1 billion kilometers. Fast forward to June 6, 2026, and boom, the spacecraft officially spots the asteroid. It spends weeks inching closer and closer until July 2, 2026, when it gets to just 20 kilometers away. 20 kilometers, that's the exact moment it snapped that historic close-up image we've been talking about.
So you might be wondering, why pick this specific rock for a mission? Well, physicist Ronqiao Zhang put it perfectly. He noted that its orbit is so close to ours, it allows for a low energy transfer. Plus, it stays at a super stable distance of about 0.1 to 0.3 astronomical units from us. To translate that, because it matches our pace around the sun so steadily, it gave scientists the absolutely perfect conditions for tracking, control, and communication. It was literally the ideal target.
But a picture is just the beginning. Let's move to our final section, a piece of our moon, the ultimate goal.
The mission goals for Tianwen-2 are honestly mind-blowing. First, study the asteroid up close to find a good landing spot, because yes, they're actually planning to land on this tiny jagged rock. After that, they want to scoop up physical rock samples and blast them back safely to Earth. The big goal here is to finally understand how on Earth these weird, rare quasi-satellites form and manage to stay near us for millions of years.
And that leads us to the most exciting question of the whole explainer. What if Kamoʻoalewa is actually a blasted fragment of our own ancient moon? Based on early telescope data, scientists seriously suspect this tiny asteroid might have been violently knocked off the moon by an ancient impact, sent drifting, and eventually got locked into this bizarre dance with Earth. Getting those samples back is the absolute only way to confirm or rule out that incredible theory. So, what do you think? Are we looking at a lost piece of our own lunar history, just floating out there in the dark? Keep your eyes on the stars, students, because we are on the verge of finding out.